Hello. I thought I would put together a full demonstration on my new 512K of course EEPROM board with external controller. I previously did one on the prototype. This is the final design with the 74 HC95 ULN 2803 chips on the back. Still mounts up to standard Radio Shack cartridge housings. The screw alignments do. And I have my 512K controller here with cable. Before I get into this, I thought it would be good to show what it takes to get the multi-bank ROM set up and the controller flashed. So I'm going to break for a few minutes and demonstrate how to get that done if you want to take it upon yourself to make your own custom setups. That's great. And then I'll come back and I will demonstrate the programmed setup. In this video section, I will take you through all the steps getting your multi-bank ROM set up and sending the configuration to your external controller. For the purposes of this video, I will assume you don't have any of these things already done. First thing we will go through is the prerequisites. You will need your source color computer files, of course, the rom.ccc images. If you have any of these standard binary images that end in the .bin extension, you should rename them to .rom or .ccc. If you leave them as .bin and load them into the multi-bank builder, it will think that they are a .bin color computer executable and add in .bin banking code, which would corrupt a standard .rom or .ccc image. Again, if you have a cartridge or .rom minor image that ends in .bin, you should rename it to .rom or .ccc before loading it into the multi-bank ROM builder tool. You'll also need the multi-bank ROM builder tool in Windows, which you can get from my site here below at tinyurl.com at QHVVNLK. You will also need the Arduino IDE at their site. And now I'll begin by going into the multi-bank ROM builder tool and showing you how to add in different types of source files to your ROM image. Loading up the multi-bank ROM builder tool. I will be working with a 512K chip for this demonstration. So I will select our 512K type. And you see we have 64 banks. Each one of these numbers represents a 8K bank. When you are using a 16K ROM, you will be using two consecutive 8K banks. And if you're using a 32K ROM, you'll be using 4. Also, .bin images will use consecutive as necessary. I will start with bank number 1 and add in, let's say, 8-ball. It will ask me to give it a name. Anything more than 20 characters will not be displayed. This will help you gauge what will be displayed on your 20 character wide LCD. You will note that it has already automatically set the appropriate configuration for that ROM. The default is auto start, which simulates a auto start jumper, and it will be code 319 for this setup. And as we put our mouse over to 319, we see the equivalent jumpers. That's pretty much all jumpers and auto start. If we change the auto to disable, we see that the code has changed. It is not necessary for us to adjust the 16K, 32K. As a matter of fact, it won't even allow it. It will set these automatically for you. I still have a 8K section over here. I cannot put anything larger than an 8K here unless it is a .bin binary, which you will automatically handle for consecutive banks. But a 16K ROM, 32K ROM cannot fit in this area. It can only fit where you see the boxes actually visible at. This is to help you maintain address control integrity. If you were to try putting a large ROM like that anywhere else, it would not work with jumpers or any other kind of control. Here I will demonstrate that by trying to add in something larger than 8K. So I will add in just another small file. And like I said, this is just a name description that you want displayed. Let's try something larger. The fence ROM is actually larger than 8K. And we see that it automatically shows that those two 8K slots are tied up by that one program. This is number 3 continued to number 4. If I want to insert a 32K ROM, such as Arkanoid, I can do that here. And see how the ROM is truncated off here. It's not that it's missing from the data, it's just that it won't be displayed on the 20 character wide controller, so it's not going to be displayed here either. I can always adjust the display name. If I want to delete a bank without actually replacing it, I can right click on it to clear that information out. If I want to insert a bin, we can change to .bin filter. And let's try Astro. And we'll see Astro fit within the 8K, so nothing else was needed. But if we had something larger, go Frogger, and then we see that it used both. A problem would arise here if I tried putting a bin file in that ran into Arkanoid. Let's see what happens there. We'll take Agate Man, which is 24K rounded. And it actually overwrote the other banks. It's not that the information is lost. It's just that the information I had put in previously is being ignored and only showing up as this. So when I go to build the ROM, those programs would not be included clear by right-clicking, and you see Arachnoid is back here. Now I will show a fully configured chip by loading a layout. It's asking, are you sure you want to lose what you're working on? Now, one thing to remember about these color codes, the blue means everything is checks out with the file. If you load a layout and you see red, that means it cannot find the file. You would just select on whatever is red and relocate the image that wherever it has moved to, and reopen, and it would change back to blue. If you leave a spot empty, that's fine. When it builds the ROM, it will automatically pad that area with hex FF and basically pad the gap and keep everything else in place so that all of these codes remain accurate. The codes are used for your sketch, Arduino sketch for the controller. If you don't have the controller, all this information can still come in handy for jumper use, and you can get a printout of this chip layout for reference. I will show that now. Chip map layout, and I'm going to title it Test 512A. And we see a PDF report of our chip layout. If I was just using jumpers, these would be the jumpers I would need to install to access that particular program. We see here I have a bunch of games, including a DriveWire boot image, DriveWire 3, and a HDB-DOS DriveWire 4, HDB-DOS DriveWire 3 for my color computer 2. So conceivably I could leave this one chip installed in the cartridge slot and access any of these without ever removing it, which would reduce wear and tear on your cartridge slot. In the controller, you can also set default ROMs, which I will get into later. Now I will build this ROM. And we see it goes through each bank. And then the ROM file is ready for flashing with your particular programmer software. The only thing left really is to get the configuration information uploaded to your controller, which I will show now. I will go into reports and generate the sketch table, which will handle the coding for you, and it will save it as a .txt text file. This is the Arduino sketch code section that I will need. I want to go ahead and copy everything. and load my sketch up. We see the previous code here can be replaced. Sure we get it all. Paste to replace. Make sure our Arduino ID is configured properly. On the right board, we go to Tools. The board should be set to Arduino Uno, and your port should be set to your COM port for your FTDI that's plugged into your USB port. And then we can hit upload, and it will compile and upload to your controller, and you'll be good to go. It will take just a few minutes. Now I will get into demonstrating the actual board in action. Okay, I'm back. I got my chip flashed and installed. I'm now going to be installing this into the Color Computer 2 with the 512K controller on the other end. This is the latest revision that has the pause controller on it. And we see my default boot up is Galax Attack. Looking at the last two digits here on the screen, we can see a 10. That means it's 16K. The last digit is 32K. It's not quite that large. I'm going to go ahead and demonstrate the pause function. I have it set to flash the pause indicator, and you can press it again to unpause. And it doesn't matter which game or HDB-DOS or anything that you have on the chip, because this is actually working directly with the 6809 halt line. So it will even pause Nitro S9, basic, anything. While you're in the pause mode, that's where you can change ROMs and set the new default. Like, say I wanted, let's pick, we'll go up to, say, HDB-DOS. So that's probably a common one that I'll be using. And let me get my DriveWire 4 version for my Color Computer 2, and I'm going to hit activate while in pause, and now it says that it's the default. I'm going to take it out of pause, and I'm going to activate this ROM, and we see the Color Computer 2 has booted into HDB-DOS 1.4. If I turn off the Color Computer, repower, it boots back into that ROM. Now I can change to different games and other ROMs without turning off the Color Computer, which is one of the great things about the controller. There are a few programs that don't seem to behave extremely well with that, and I believe I have some of them on here. So let me go all the way back down to my first bank and I'll go through them and we'll see how they act. First one I have on here is Flight Simulator 1. It is a .bin file that is using the banking features of the controller. It actually uses two 8K sections. So when I activate, you will see a bin and then which section number starting with 0 right beside it. And then when the bin goes away, it stops waiting for signals from the loader. It's no longer monitoring the SCS line. One of the things I noticed when I started working with these bins on the Color Computer 2 and Color Computer 3, it seems like the actual cartridge loading happens pretty fast. It loads the 8K chunks pretty fast, but there's a delay before it even gets there. I think the Color Computer is loading its own internal ROMs. The Color Computer 3 seems to do that a little faster, but that's the only reason there's as much a delay as there is. Androne is a standard ROM. Color Baseball, that's a standard 8K. Here we have the Radio Shack Diagnostics version 2. And again, I'm just activating the ROM from the controller. I'm not even power cycling the computer. So there are a few games I think we'll get to that have some issues with that, and I'll show some workarounds. There's Downland. Etasm. And Etasm was 16K. Micro Chess. Personal Finance. Pinball. 8-ball. Tetris. Tetris is 16K. Astroblast. Offender. Defense. Frogger 16K. There's the Lax Attack 16. Invaders 16K. Polaris. Assault is a binary, it's only 8K. Just want to stay at 0. Zaxxon was interesting. It was only possible due to the banking feature because it actually goes up beyond the 16K and it required 3 sections, so this was a good way to get it onto a chip. You'll see 0, then 1, then 2. See, here we go. Here's one of those problem ROMs. I'm trying to activate Zaxxon, but Space Assault doesn't want to let go of the computer. I'm not exactly sure how to get the Color Computer to completely reset. If I do a actual reset button, it will go back to the extended color basic prompt, and then I can activate Zaxxon. So that's one of those workarounds I was talking about. So I don't know what the reset button is doing differently than what I'm doing. I am actually triggering the halt and the reset when it reboots the ROM. So I don't know if there's something extra I can do on the cartridge interface to help with that or not. Like I said, it only affects certain programs. Baggett Man's also a binary, and there was never a trigger, that's why it stayed at 0. And we see that went into 3 sections, 0 through 2. Donkey is a binary. This is a funny one. I'm not sure if it's supposed to do this or not. I have a blue screen. I can press spacebar and then it runs fine. Maybe that was the way it's supposed to do. I don't know. Monopoly was pretty large. That's binary. Airplane, binary. Junior. Megabug works pretty good. This is the DriveWire 3 DOS, which tries to boot your DriveWire 3 Nitro S9 from the server. If I do it now, it's going to fail because my server is not running. And then of course my DriveWire 4 and DriveWire 3 16K HDB DOS ROMs. There's the 4. There's the 3. And I have the message on the screen is slightly different, so I can confirm which one is which. Demolition Derby. 8K. Galactic Attack. Arkanoid is a 32K ROM, demonstrating the 32K mode. Works very well on both the Color Computer 2 and Color Computer 3. Demon Attack is also 32K. Works very well on both machines. So we got another unhappy reset there. A little garbage. Let me try that one more time. And yeah, the computer's not liking it. So I'm going to actually press the reset button and then activate it again. And there we go. It's like some programs just don't want to let go. And then we go to Super Pitfall. Now this one is one, I think it's doing something strange. It's supposed to be a 32K ROM, but I cannot get it to load on either my Color Computer 2 or my 128K Color Computer 3. All I get is, well, that. And I can reset, activate, and it just sits there. If I go into pause and make this the default, it still doesn't work. So far that's one of only like maybe 2 games that I found in a .rom file that would not load. The other one being Mine Roll, and according to what I found on a disk image, takes some very special loading to get it to load properly. But any normal program loads very well. I did end up putting the controller on 10mm standoffs. And the brightness trim pot was added. I had to determine which values would work the best. On the brightness trim pot, and you can disregard the 10 microfarad capacitor here. That was just me testing for power stability. It was not required on the ones I will be building. That will not be there. The brightness at 1K trim pot allows full control. The 10K trim pot, for contrast, allows full control. I did experiment with a 500 ohm trim pot for brightness, and that allowed more fine control, but you would never be able to totally turn off the backlight by using the trim pot. You could do it in software because the backlight is in the sketch as enabling when the buttons are pressed, and after a 60-second countdown, the backlight goes off. So that's manageable in software. But that's it. Works very well. Thanks for watching.